Okay, welcome back, Stella. Hope you are doing well. I saw the assignments you did. It was the first part, exercises on type 4. This first part, that's what you did. You did everything well. I'll just talk about some important points that I noticed that you have to correct. So let me go to your solving. Let me go to your solving. I'll open some images. I'll open some images that I observe some things that you need to rectify. You understand? Okay, let's go for example on image 18. You go to your textbook. You were integrating which exercise is it again? Yes, this exercise. Question 9. You were doing question 9, the integral of dx on 3 sine x plus 4 cos x. Let me go question 9. So this is it. This is the question 9. This is what you were doing. So there is a small thing I want to mention here. When you are doing, look at this, what you wrote here. You wrote here, so you were finding cos x naturally. You said recall cos nx equals to 2 cos square nx minus 1. Very correct. But here you wrote cos nx equals to adjacent all over hypotenuse, which is 1 all over the square root of 1 plus 1 plus t square. It is not cos nx, it is cos x on 2 from your triangle. What you are supposed to do here, after writing this formula, let me go to a sheet of paper. Let me go to a sheet of paper. What you are supposed to write is what? When you say recall that cos nx. Wait a minute. When you say recall cos nx equals to 2 cos square nx on 2 minus 1. You have to write directly. This is a recall. You are just recalling a formula. You have to write directly. It implies that because according to what you are using, you have to find what? What are you finding? You are finding cos x. It's cos x that you are finding. So you will write, it implies cos x. So the n here becomes 1. So here it becomes also 1. Cos x being equals to what? 2 cos square x on 2 minus 1. That's what you are supposed to do before doing this, before writing that cos x on 2, not cos nx on 2, cos x on 2. Is that okay? So that's the first observation I had to do here. So for the next observation, let me go to image 24. For the next observation, image 24, let me see the exercise you were doing. Let me go back. Okay, let me first, for you to know which exercise you were doing. This is the integral you are finding. Integral of, let me go to the question. Let me go back. Wait. This is the integral you are finding. I hope that's the integral. Yes, that's the integral you are finding. Integral of dx on 3 sine x plus cos x. There is something you did here. Let me go in front. Let me go. Yes. Here at this level, never forget, when you leave from here to here, you've already integrated. Don't forget your constant of integration. Write your constant plus your constant of integration outside here. Because these two multiply all this, but your constant, you have plus a constant of integration. With k, precise your k belongs to r. Here, you forgot the constant of integration plus k. Always precise your constant of integration. That was the next observation I had to make. For the next observation, let's go to image 28. The next observation, image 28. What exercise were you doing even? Let me check. This exercise, question 10. Integral of dx all over 1 plus sine x minus cos x. Okay. The observation here is at the level of, let me see. Okay, at this level. Why do you waste time to calculate delta? Why do you waste time calculating delta here? It's true, it is a quadratic equation, but there is no need to waste time to calculate here. You just factorize your t here. Do you understand what I'm saying? Instead of wasting time and first calculating delta, this is a straightforward thing. You could just observe that when you factorize t, it becomes t into t plus 1, and you continue. This is not a this is not a situation where, let me go to a sheet of paper. This is not a situation where you have maybe t squared plus t plus something, let's say plus 2, that you have to calculate delta. You have directly t squared plus t. There's no need of calculating delta here. You just factorize your t and it becomes t plus 1, and you express directly in partial fraction. I don't know if you are trying to get what I'm saying. So there was this is time wastage. This is time wastage. What you did is correct, but this is a wastage of time. You understand what I'm saying? This is wastage of time. So always be very concentrated when you are doing things. For the next observation, let me go on the image 31. Let me go on it. Okay, the observation here was at this level. Look at something. Look at something. It's true at this level. When you leave your, let me zoom. When you, this is already, it's true, you've already integrated. You say that, recall that t was equals to this, and you substitute. But there's something. Always try to simplify things as much as possible. This is ln of a minus ln of b. Why do you not write it in a more simpler form instead of leaving things like this? You have, let me go on a sheet of paper. You have ln. You have ln of the absolute value of t minus ln of the absolute value of t plus 1. Let me check if it is that. Yes, exactly. This is ln of a minus ln of b. This becomes what? Ln of a on b. Always try as much as possible to simplify things as much as possible, because at times they give marks for you to simplify things as much as possible, and you will lose marks if you don't do that. Here, you just write this as ln of what? Of the absolute value of t all over what? The absolute value of t plus 1. Now, I told you that the absolute value of a all over the absolute value of b is the same as the absolute value of a all over the absolute value of b. So this becomes what? This becomes ln of what? You put absolute value of what? T all over t plus 1. That's how you are supposed to simplify it as much as possible. From there, you come and substitute your t was equals to what? Tan x on 2. You come and substitute it. It gives ln of the absolute value of tan x on 2 all over what? Tan x on 2 plus 1. You close your absolute value plus your constant of integration plus k plus k. So always try as much as possible to simplify things. It's very important because there are always marks for the final answer. If you don't simplify as much as possible, you may lose some marks. You understand what I'm saying? So that's it. Let me talk again on another observation that I saw. Let me go on the image 39. Where is it even? 39. Image 39. Image 39 What was my observation even? Image 39. Okay. At the level of this image 39, let me zoom for you to see things clearly. Okay. This was, let me first go back for you to know the question I'm talking of. Let me go back. Let me go back. Okay. We were in equation 11. We were integrating integral of g theta all over 3 plus sine 3 theta plus cos 3 theta. Okay, let me go where I want to make the observation. Look at something here. This, it's still, the observation I want to make is still on simplifying things as much as possible. Look at something. Let me zoom. You have minus 1 on root 3, on 3 root 10 here, which is common. You have 1 on root 3 on 3 root 10. That's still common here. Why do you not factorize this? You have to factorize all this. There is 1 on root 10 here, which is common. 1 on 3 root 10 here, which is common. You factorize it outside. That gives you what? Let me go. You have minus 1 on 3 root 10 ln of the absolute value of what? Of the absolute value of t minus 3 root 10 of t minus 3 root 10 plus 1 on 3 root 10 ln of t minus 3 plus root 10 ln of the absolute value of t plus 3 plus root 10 plus our constant of integration. You have to simplify things as much as possible. There is 1 on 3 root 10 common here. You factorize it. You have 1 on 3 root 10, 3 root 10 into what? Into what? Ln of this, of the absolute value of t plus 3 plus root 10 minus what? This one. Ln of the absolute value of what? T minus 3 minus root 10 plus our constant of integration. When you do, okay, there is a bracket here. When you do this, you know that this is like ln of a minus ln of b. This becomes what? 1 on 3 root 10 ln of what? Your brackets, absolute value of t plus 3 plus root 10. You close your absolute value all over the absolute value of what? This t minus 3 minus root 10. You close it. Now, you also know that the absolute value of a all over the absolute value of b is what? Absolute value of a on b. So you apply it here. This, you have it plus your k. This becomes equals to what? 1 on 3 root 10 ln of the absolute value of t plus 3 plus root 10 all over what? T minus t minus 3 minus root 10 plus your constant of integration. Now you come and substitute your t. That's how you are supposed to simplify things as much as possible. Don't just leave your answer like this. It's true, you have the answer, but you can simplify things as much. You can simplify things as much as possible, because at times they can ask you to prove that they give you an integral, they ask you to prove that your result will be this. You will leave your answer like this. You will not have the answer. Try to always simplify things as much as possible. There was 1 on 3 root 10 common here and here. You factorize it outside and you simplify these things. So that was the last but not the least observation I had to do. So always try to simplify things as much as possible. Then the last observation on these assignments is image 45. Image 45. Let me go on it. The same thing here. Look at this. Let me zoom on this. Let me first show you which exercise it is. So we're integrating question 12. Integral of g theta over 8 cos 5 theta. So Here is the observation I want to make again. At this level, first of all, you forgot your constant of integration. Never forget that. The next thing again, you can simplify this. You could simplify it even here. You can simplify this as much as possible. There is 1 on 40 common here, 1 on 40 common here. You factorize and you arrange the limb. Is that okay? Try to always simplify things as much as possible. Try to simplify things as much as possible. So you basically did a good job. You did a very good job in solving your exercises. That shows that you mastered things very well. So I'll not waste my time again solving this, like this question. You know already how you will solve it. The substitution here will be t equals to tan what? The substitution here will be t b equals to what? Tan this angle x divided by 2. Is that okay? Which question I had to do again? The substitution here again will be t equals to what? Tan x on 2. Which question will I was I supposed to do again? The same thing here. The substitution is here will be t equals to what? Tan 5 theta divided by 2. Is that okay? So I'll just do the next video. I'll just do this question because you did not do it. It's true. I marked a star for me out to do it. So the next video that will be coming, I'll find this integral and I'll prove that basically I'll find the integral of cosec theta. I'll prove that the integral of cosec theta must be equals to ln of the absolute value of cosec theta minus cot theta plus a constant k, which is still equals to what? Ln of the absolute value of tan theta on 2 plus a constant k. We have already proved this one. We've proved this one already. So I'll prove this one in the next video, and I'll also do the other exercises. So see you in the next video. You did a very good job. So continue working like that.